Hi, welcome to today's class on my lesson teacher. Today's class is a continuation of our previous classes on number-based system for senior secondary 1. At the previous class, we were able to convert numbers in base 10 to other bases after I did explain to you the different number system that we have. We're able to convert numbers in base 10 to other bases. We also dealt precisely on converting numbers in other bases back to base 10. In today's class, we shall be taking the third objective, which is to convert decimal fractions in other bases to base 10. We have seen how to convert numbers from base 10 to other bases, as well as from other bases to base 10. In this next example, we shall be dealing with fractions. And how do we convert numbers involving fractions from other bases to base 10? I have an example here for us to solve, that we should convert 101.111 base 2 to base 10. We just have two steps to take in treating this. For us to convert these numbers to base 10, we have to multiply each of the digits by the base all raised to a power, and that power is a function of the place values of these digits. That is, what am I saying in essence? 101.111 base 2, I'm going to express it in the expanded form by multiplying each of them by a power. So remember that in our previous class, for us to convert from other bases to base 10, we multiplied this, for example, using the expanded form by saying 1 times 2, which is the base, raised to a certain power, and which we said the power is a function of its place value. That is, the first digit to my left after the decimal, before the decimal point, we'll take the place value 0, while this will have a place value 1 and this 2, such that you multiply 1 times 2 raised to the power of 2 plus 0 times 2 raised to the power of 1 plus 1 times 2 raised to the power of 0. So I'm going to expand these digits by, okay, let's first of all assign the place values to each of the digits. This is said to be 0, 1, and 2, while digits to your right from the decimal point will be assigned place values less than 1, that is, negative place values. So the first digit is going to have a place value of -1, the second will be -2, and the third will be -3. So I'm going to multiply each of these digits by the base, all raised to the power based on their place values, such that this becomes 1 times 2 raised to power 2 plus 0 times 2 raised to power 1 plus 1 times 2 raised to power 0 plus 1 times 2 raised to power -1 plus 1 times 2 raised to power -2 plus 1 times 2 raised to power -3. This is the first step in solving this problem. Next, what I'm going to do is to simplify them until I arrive at an answer. That is, this is equal to 1 times 2 raised to power 2 can be said to be 2 times 2, and 2 times 2 is 4, plus 0 times 2 raised to power 1 is said to be 2, plus 1 times 2 to power 0 is said to be 1. That is, anything raised to power, any number raised to power 0 is said to be 1, plus 1 times 2 to power minus 1 is said to be half, plus 1 times 2 to power minus 2 can be said to be 1 over 2 raised to power 2, and 2 raised to power 2 is 4, plus 1 times 2 to power minus 3 is said to be 1 over 2 raised to power 3, and 2 raised to power 3 is said to be 8. I'll simplify further. This is going to give us 1 times 4 is 4, plus 0 times 2 is 0, plus 1 times 1 is 1, plus 1 times half is said to be half, plus 1 times 1 quarter is said to be 1 quarter, plus 1 times 1 over 8 is said to be 1 over 8. You simplify further. This will be equal to 4 plus 0 plus 1 is said to be 5. That is for the whole number part, plus our fraction. I'm going to find the LCM of 2, 4, and 8 so as to add them together. When you are solving sums of fractions whereby the denominators are said to be different, you have to get a new denominator for this solution. So if I'm to add half plus 1 over 4 plus 1 over 8 together, I'm going to use the LCM method. What's the LCM of 2, 4, and 8? The LCM is said to be 8. I have gotten a new denominator for these fractions. To get a new numerator for this expression, I'm going to divide the new denominator, which is 8, by each of the old denominators to be multiplied by the old numerators to get the new numerators for this expression. That is, 8 divided by 2 is said to be 4. 4 times 1 is 4. Plus, I have gotten the new numerator for the first fraction, half, which if you divide 4 over 8, it is still the same thing as half. I'll also do same for the second fraction by saying 8 divided by 4 is 2. 2 times 1 is 2. Plus, do same to the last. 8 into 8 is 1. 1 times 1 is 1. Simplify further. This is equal to 5 plus. Now sum up the numerators. This becomes 4 plus 2 is 6 plus 1 is 7, all divided by 8. And when you simplify this further, your answer becomes 5 whole number 7 over 8. By this, I have been able to convert 101.111 base 2 to base 10. So this is the way to convert fractions, numbers involving fractions, from other bases to base 10. Let's take another example. In this example, we are asked to convert 1.011 base 2 to base 10. It is not different from what we did in the first example. We are going to take 2 steps. The first is by using the expansion method to express 1.011 base 2 in the expanded form. Thereafter, we simplify to arrive at our answer in base 10. So this becomes 1.011 base 2. We are going to expand it now, but before we do that, we are going to determine their place values. This becomes 0, this is -1, -2, and -3. So you multiply each of these digits by the base, all raised to the power of their place values. This becomes 1 times 2 raised to the power of 0 plus 0 times 2 raised to the power of -1 plus 1 times 2 raised to the power of -2 plus 1 times 2 raised to the power of -3. We'll simplify further. This is equal to 1 times 2 raised to the power of 0 is said to be 1 plus 0 times 2 raised to the power of -1 is said to be half plus 1 times 2 raised to the power of -2 can be said to be 1 over 2 raised to the power of 2 plus 1 times 2 raised to the power of -3 can be said to be 1 over 2 raised to the power of 3. That's 2 cubed. We'll simplify further. This is going to give us 1 times 1 is 1 plus 0 times a half is 0, because anything times 0 returns a value 0, plus this becomes 1 times 1 over 2 raised to the power of 2, or 2 squared, can be said to be 4, plus 1 times 1 divided by 2 cubed, and 2 cubed is said to be 8, because 2 cubed is said to be 2 times 2 times 2, and 2 times 2 will give you 4, which when multiplied by 2 is said to be 8. So we'll simplify further by summing. 1 plus 0 is said to be 1, plus 1 times 1 over 4 is said to be 1 over 4, plus 1 times 1 over 8 is said to be 1 over 8. This becomes 1 plus, find the LCM of 4 and 8 is 8. 4 into 8 is said to be 2. 2 times 1 is 2, plus 8 into 8 is 1, and 1 times 1 is 1. When you simplify further, you arrive at the answer 1 plus 2 plus 1 is 3 all over 8. And when you simplify, this is going to give us one whole number 3 over 8 as our answer. So that 1.011 base 2 is said to be equivalent to one whole number 3 over 8. And when you convert this back to base 2, you simply get back your answer. Let's take another example. In this example 3, we are asked to convert 14.311 base 5 to base 10. Not just only in base 2. Let's see how we can convert from other bases other than base 2 to base 10. We'll still take the same procedures, which is to first of all assign the place values to each of the digits. Thereafter, you expand them as a product of their base all raised to the power of their place values and simplify. Take these few steps and you discover it is as easy as ABC. So we have it as 14.311 base 5 is equal to, their place values is, this is 0, this is 1, this becomes -1, -2, and -3. So by expansion, we have 1 times 5 raised to the power of 1 plus 4 times 5 to the power 0 plus 3 times 5 to the power of -1 plus 1 times 5 to the power of -2 plus 1 times 5 to the power of -3. We have expanded them. Let's simplify further. This is equal to 1 times 5 raised to the power 1 is said to be 5, plus 4 times 5 to the power 0 is said to be 1, plus 3 times 5 raised to the power of minus 1 is said to be 1 over 5, plus 1 times 5 to the power minus 2 is said to be 1 over 5 squared, plus 1 times 5 to the power minus 3 is said to be 1 over 5 cubed. Let's simplify further. This becomes 1 times 5 is 5, plus 4 times 1 is 4, plus 3 times 1 over 5 is said to be 3 over 5, plus 1 times 1 over 5 squared. 5 squared is said to be 5 times 5, and 5 times 5 will give you 25. So 25, 1 times 1 over 25 is said to be 1 over 25, plus 5 cubed is said to be 5 times 5 times 5, and 5 times 5 will give you 25. 25 times 5 will give you 125. So 1 times 1 over 125 is said to be 1 over 125. When you simplify further, you add up the whole number part as well as the fractional part, such that 4 plus 5 will return a value 9, plus we'll look for the LCM of 5, 25 and 125, which is 125. 125 divided by 5 is said to be 25, and 25 times 3 is said to be 75. So this is 75 plus 125 divided by 25 is said to be 5, and 5 times 1 is 5, plus 125 divided by 125 is said to be 1, and 1 times 1 is 1. I hope you are understanding. Let's simplify further. This becomes 9 plus 75 plus 5 is 80. 80 plus 1 gives you 81 divided by 125. And this is equal to 9 plus 81 divided by 125 can be said to be, I'm going to use my calculator to get the value. So 85 divided by 81 divided by 125, 81 divided by 125 is said to be 0.648, and when you add it to 9, it gives you 9.648. This is our equivalent in base 10. Let's take one more example. In this example 4, we have to convert 21.12 base 3 to base 10. Follow the same steps we have been doing in the previous examples, and you are not far from the answer. This becomes 21.12 base 3. Give them the place values. This becomes 0, this is 1, this is minus 1, and this is minus 2. So you express them in the expanded form. This becomes 2 times 3 raised to the power of 1 plus 1 times 3 raised to the power of 0 plus 1 times 3 to the power minus 1 plus 2 times 3 to power minus 2. So we have expanded it. Let's simplify. This becomes 2 times 3 raised to power 1 is 3 plus 1 times 3 raised to power 0 is 1 plus 1 times 3 raised to power minus 1 is said to be 1 over 3 plus 2 times 3 raised to the power of minus 2 is said to be 1 over 3 squared, and 3 squared is said to be 9. So when you simplify this further, this becomes 2 times 3 is 6 plus 1 times 1 is 1 plus 1 over 3 plus 2 over 9. Let's simplify further. 6 plus 1 gives us 7 plus, find the LCM of 3 and 9, which is 9. 9 divided by 3 is 3. 3 times 1 is said to be 3 plus 9 into 9 is 1. 1 times 2 is said to be 2. Let's simplify further. This becomes 7 plus 5 over 9. And when you divide 5 by 9, it gives you a value. Let's see. 5 divided by 9 is 0.55556. So 2 or 3 places of decimal, we are going to have 0.556 as our answer. Then when you sum them together, this becomes 7.556 to 3 decimal places. So this is our answer. Before we go, let me give you one to try. You have to convert 24.042 base 5 to base 10. Just like I told you, you have 3 steps to take. First is to assign a place values to each of these digits. Digits to your left, beginning from the decimal point, you have to assign positive values to them beginning from 0. While digits to my right will be assigned negative values beginning from -1 to infinity, to minus infinity. When you are done expanding them, then you simplify. So these are the 3 steps to take in solving this example. I hope you now understand how to convert numbers involving fractions from other bases to base 10. At the end of this class, we have been able to solve the 3rd objective, which says to convert decimal fractions in other bases to base 10. In our next class, we shall be looking at the 4th objective, which is carry out operations involving addition, subtraction, multiplication and division of numbers in base 10. Do well to subscribe to our channel if you have not done so. You can also follow us on Facebook. You can also use the comment section to interact with us, and also share to your families and friends, most especially those who are in need. Do well and have a nice day. Thank you.